Imagine a group of dancing cartoon bubbles, a trio of animated pandas, or a classroom of students all moving in perfect unison, each with their own unique style, shape, and personality. Now imagine generating this kind of rich, coordinated multi-subject animation from just one driving pose sequence and a single reference image, even if the pose doesn't match the layout of the characters in the image. This isn't science fiction. It's CoDance, a new framework that redefines how we animate multiple characters in a single scene, overcoming long-standing limitations in current AI animation systems. Let's dive into why this matters, what's broken in today's models, and how CoDance fixes it with a clever two-step strategy: unbind and rebind. The problem: rigid binding breaks multi-subject animation. For years, AI-powered character animation has excelled at one thing: animating a single person. Given a reference image and a sequence of poses, say, someone dancing, models can generate realistic, lifelike videos. But when you move to multiple subjects, things fall apart. Why? Because most models rely on a rigid spatial binding between the pose and the reference image. They assume the pose skeleton must align pixel for pixel with the subject in the reference. If the pose is slightly shifted, scaled, or if there are more characters in the image than in the pose, boom. The model fails. It doesn't understand motion, it sees position. So when the input is misaligned, it hallucinates a new person in the right spot, ignoring the actual characters in the image. The result: identity confusion, motion misassignment, or entire subjects left unmoved. Even the best models today, like Animate Anyone or Stable Animator, struggle beyond two subjects. They're built for one-to-one mapping. Scale them up. They break. And that's not all. These models are also brittle when it comes to non-human subjects: cartoons, animals, abstract characters. They're optimized for real humans and fail to generalize. So the core problem is this: over-reliance on spatial alignment. The model treats the pose as a direct spatial blueprint, not a motion signal. Enter CoDance, a paradigm shift in character animation. Instead of forcing alignment, CoDance breaks it, then rebuilds it using a dual-phase strategy: unbind and rebind. Phase 1, unbind, free the motion. During training, CoDance deliberately breaks the spatial link between the pose and the reference image. How? By applying stochastic perturbations to both the pose and its latent features. Specifically, at every training step, the pose skeleton is randomly translated, shifted in XY, and scaled. The pose's latent representation is further augmented. We extract the pose region, duplicate it randomly, and superimpose the duplicates onto the feature map. This forces the model to stop relying on pixel-level alignment. It can no longer say the pose must be here, because the pose keeps moving. Instead, it must learn to understand motion semantically, what a wave looks like, what jumping feels like, regardless of where it appears in space. This is the Unbind module, a pose shift encoder that teaches the model to recognize motion independent of position. As a result, the model learns a location-agnostic motion representation, one that's robust to misalignment, scale changes, and even different numbers of subjects. Phase 2, rebind, reattach motion to the right characters. Now comes the tricky part: how do we tell the model which characters to animate? After unbinding, the model knows what motion is, but not who it should apply to. That's where rebind comes in: two complementary mechanisms. First, semantic guidance via text prompts. We add a text encoder branch. When you input a prompt like 5 anthropomorphic bubbles are dancing, the model uses that to identify how many subjects to animate and what kind they are. But here's the catch: animation datasets often have repetitive, generic prompts. If we train only on these, the model learns to match patterns, not understand meaning. So CoDance uses a mixed data training strategy. It alternates between animation data and a large, diverse text-to-video dataset. This forces the model to develop a deeper understanding of language, so it can respond to any prompt, not just the ones it's seen before. Second, spatial guidance via subject masks. Even with good semantics, ambiguity remains. What if two characters look similar? Or the background has a shape that mimics a subject? To fix this, CoDance uses an off-the-shelf segmentation model, like SAM, to generate high-quality masks for each subject in the reference image. These masks are fed into a mask encoder, which produces spatial features. These features are then added element-wise to the latent representation during diffusion. This ensures the motion is strictly confined to the regions defined by the masks. No more background animation. No more missing limbs. Together, semantic and spatial guidance form the rebind module. It re-anchors the motion to the correct subjects, even when the pose is misaligned. Why this works: a new paradigm for robust animation. The magic of CoDance lies in its dual-phase decoupling. Unbind teaches the model to understand motion independently of position. Rebind gives it the tools to reattach that motion to the right subjects, using language and spatial context. This means CoDance can handle arbitrary subject counts, 1, 2, 5, or 10, no limit. Arbitrary subject types, humans, animals, cartoons, abstract shapes. Arbitrary spatial layouts, subjects can be in any position, orientation, or scale. Arbitrary pose alignment, the pose doesn't need to match the reference image's layout. And crucially, no per-subject alignment is required. One pose sequence, one reference image, and the model figures out the rest. Real-world validation, benchmarking the state of the art. To test CoDance, we built a new benchmark. CoDanceBench, 20 multi-subject dance videos with diverse characters, complex motions, and intentional pose-image misalignments. We compared against 8 SOTA methods: Animate Anyone, Animate, Stable Animator, Animatex, and more. The results: CoDance outperforms all competitors across every metric. LPIPS down arrow, lower perceptual error right arrow, more natural-looking videos. PSNR up arrow / SSIM up arrow, better identity preservation and structural similarity. FIDVID, FVD down arrow, more realistic video distributions, less mode collapse. Even in the hardest case, animating a multi-subject image with a single-person pose, CoDance succeeds where others fail. The model correctly assigns motion to each subject, preserving identity and coherence. User studies confirmed this. Participants preferred CoDance in 90% of cases across video quality, identity preservation, and temporal consistency. And ablation studies proved the necessity of both modules. Remove unbind. Identity loss. Remove rebind. Motion is unlocalized. Only the full system delivers robust, accurate results. Technical foundations, built on a strong backbone. CoDance is built on WAN 2.1, a large-scale diffusion transformer, DI-T, model trained on text-to-video data. We initialize it with pre-trained weights and fine-tune using LoRa, a lightweight, efficient adaptation method, only on the attention layers. The pose encoder uses 3D convolutions to capture both spatial and temporal dynamics in the pose sequence. The reference image is encoded via a VAE, and the subject masks are processed by a stack of 2D convolutions. Crucially, unbind and mixed data training are only used during training. At inference, the model runs at full speed, no extra overhead. Conclusion: a new era for multi-subject animation. CoDance isn't just another incremental improvement. It's a paradigm shift, the first framework to simultaneously achieve all 4 arbitrary properties. Arbitrary subject counts, arbitrary subject types, arbitrary spatial configurations, arbitrary pose alignment. It solves a fundamental flaw in current animation models, the over-reliance on rigid spatial binding. By unbinding motion from appearance and rebinding it with semantic and spatial guidance, CoDance unlocks robust, flexible, and scalable multi-subject animation. From entertainment and education to advertising and virtual avatars, this is the future of character animation. The code, models, and CoDanceBench dataset will be open-sourced soon. So go ahead, try it yourself, and start animating your own group dances, no alignment required.